Good morning, guys. Today we're going to be looking at finding rational zeros and factors of polynomials. Zeros, again, are x-intercepts, and factors are terms that have where you have to kind of do the opposite of solving for x, which we talked about last class or last lesson. But the objective is we will be able to find the rational zeros of a polynomial function using synthetic division and factoring. Okay, so we talked about synthetic division last class, and we've been working with factoring. We had a test on factoring, and so we're going to be using these two skills to find the zeros. And rational just means anything that can be a fraction or a whole number, rational zeros. And then we will be able to determine the factors of a polynomial expression. So today we're just going to do two examples, one covering the first bullet point and a second one covering the second bullet point. So today we're going to use the synthetic division and factoring skills we have developed to find the rational zeros of polynomial functions. Then we will use what we learned in the last lesson to determine the linear factors of polynomial expressions. And again, the linear factors are what we spoke about in the last lesson, towards the end of the last lesson. If you remember the P over Q, that's what we're going to be using as well. Those are the rational zeros. So let's look at the steps. There's 3 steps to find the rational zeros of a polynomial. You have to list all the possible rational zeros. So if you remember in the last lesson, we did P divided by Q. So that's this first step here, is doing all the P divided by Q parts. And the new thing that we're doing today is step 2 and 3. We're testing the values that we get with the P and the Q, and we're going to be using the synthetic division. And we're looking for values of x. When we say testing the zeros, we're looking for values of x that give a remainder of 0. So when we're testing these zeros, these x-intercepts, remember we call zeros x-intercepts, right? So we're testing the x-intercepts using synthetic division, and what we're testing for is making sure that that x-intercept, or that 0, is going to give you a remainder of 0. So again, I'm going to show you what that looks like in the example today. And then after you use synthetic division, you're going to see what's left over. Okay, because remember when we did synthetic division, there was usually an expression that was left over. And we're going to see, can we factor that expression to find all the x-intercepts? So again, we're using that term again, zeros, which means x-intercepts. Okay. So again, we're going to list all the possible zeros doing the P over Q method that we did last lesson. Then we're going to use synthetic division, which we did 2 lessons before. And then we're going to factor, which is what we did on the past test. So this is why we've been kind of breaking up the lessons into parts, is to kind of prepare you for this process. Okay, so, and the second example that we're going to work on is we're going to determine the factors of polynomial expressions. To determine the factors of a polynomial expression, we will use the rational zeros that we found and write them as linear factors. Okay, so we're basically going to do this process, steps 1 through 3. But then after we get our answers, we're going to write them as factors. Okay, so to kind of cover what I mean by factors, I'm going to open kind of a blank page before I get to the examples. But if you remember from last class, and I'm just going to use a blank page here. So remember, we would get the zeros, and let's say our zeros ended up being, let's say x equals -2 and x equals x equals 3. So we would, these were the zeros. If I wanted to change them into factors, we would do +2 +2, and that gives me x plus 2 equals 0. And then on the right over here, we would do -3 -3. That gives me x minus 3 equals, what's 3 minus 3? 0. So I ended up with these factors. I don't like the way that S came out. Factors, right? So I can write it as x plus 2 and x minus 3. Okay. So this part here is a factor, and this right here is a factor. Right, so if I had 2 zeros last lesson, I can change the zeros notation into factors notation, which is just the opposite, right? The opposite of -2 is +2. The opposite of a +3 is a -3. So that's what we're going to do in the second example. We're going to end up with getting like values of x as our x-intercept, and then we're going to write them as factors. Okay, so let's look at this example. It says, find all the rational zeros of the polynomial function. Find all the rational zeros of the polynomial function, show all your work. So this is going back to that P over Q method. And so remember, the P that we were using was the constant term, the term without an x. And then the Q came from the leading term, the term with the highest power. What's the number in front of x to the third if there's no number written? It's a 1. So this is going to be my Q. So I found the P value, I found the Q value. Now, with the P value, we're listing all the different ways to multiply to get 12, right? So I could do 1 times 12. I could do 2 times 6. And 3 times 4. But I'm going to write them in order from least to greatest. So Let's write them out again. So we have 1, 2, 3, 4, 6, and 12. Okay, so again, 1 times 12, 2 times 6, 3 times 4. These are all different ways to multiply to get 12, right? And we're considering all the positives and negatives. Okay, and then with the q value, well, it's an easy one, right? It's just 1. How do you get 1? What are different ways to multiply to get 1? Just 1 times 1. So 1 is my only value there. Okay, so after I find the p's and the q's, the different ways to multiply, then I'm going to find all the different ways to divide p over q. So that's going to equal, okay, so what's 1 divided by 1? 1. What's 2 divided by 1? 2. What's 3 divided by 1? And I think you should see a pattern, right? So 4 divided by 1 is 4. 6 divided by 1, 6. 12 divided by 1. And all of these are going to have plus and minus. All right, so now that we found all the possible zeros, all the possible x-intercepts of the graph, we're going to use these values to divide this expression using synthetic division. Okay, so this expression at the very beginning, I'm going to divide this expression by one of these values. And we have to test them out. We have to see which one is going to give us a remainder of 0. So I always like to start with the smallest first. So 1 is the smallest, and I can choose between a positive or negative. So it's our choice. We can choose. I mean, I could choose to start with 6. I could choose to start with 4. But like I said, I like to start with the smallest number, which is 1. And then from the smallest number, I have 2 choices. I can choose positive 1 or negative 1. So let's go with positive 1. If positive 1 doesn't work, then we'll try negative 1. Okay, so let's set it up. Okay. So what we're going to do is I'm going to copy, or not copy, but I'm going to set this up like for synthetic division. So remember, for synthetic, we're just going to use the numbers in front of the x's. So the number in front of the first x is 1. Then the number in front of x squared is 2. Then the number in front of negative 11, the number in front of x is negative 11. And then the last number is negative 12. And so we're doing synthetic division. And remember, in synthetic division, we bring the first number down, and then we multiply the number outside times 1. But this is where I'm saying we have different numbers to choose from. I could choose positive 6, I could choose negative 4, I could choose negative 3. But I like to start with the smallest one, and we're going to try out positive 1 first. So positive 1. Okay, and so let's do the process. So we multiply. What's 1 times 1? It's, oh, sorry. Okay, let's try again. What's 1 times 1? That is 1. So that goes over here. Then what's 2 plus 1? It's 3. And then we're going to do what's 1 times 3? That's 3. Then what's negative 11 plus 3? It's negative 8. Then what's 1 times negative 8? 1 times negative 8. That's negative 8. Then what's negative 12 minus 8? It's negative 20. So my remainder is negative 20. So again, I tested this value, and what I was testing for is I wanted to test to see if I got a remainder of 0. So I tested positive 1 to see if when I did synthetic division with that value, did I get a remainder of 0? No. All right, so then let's try another number. So I'm going to erase positive 1, erase these answers here. Okay, it's kind of like I'm resetting here, right? So let me fill in some of the black lines that I removed. Okay, bring down the first number. Okay, so again, we tested out positive 1. So I'm going to cross out positive 1. So positive 1 did not work. So let's try negative 1. And let's do the process again. So what's negative 1 times 1? It's negative 1. Then what's positive 2 minus 1? It's 1. Then what's negative 1 times 1? It's negative 1. What's negative 11 minus 1? It's negative 12. What's negative 1 times negative 12? Negative 1 times negative 12, that's positive 12. And then what's negative 12 plus 12? 0. So this is my remainder. Awesome. So notice, right, we tried it with positive 1, and it gave us a remainder of negative 20. So we said, okay, that's not what we wanted to get. So then we reset the process, and then we tried it with negative 1. And so again, we tested out this value to see if we got a remainder of 0. Did we get a remainder of 0? Yes. So check mark. Okay, so what would we do next as far as synthetic division goes, right? We would say, okay, what was the power of the problem originally? It had the power of 3. So when I use these numbers from my synthetic process, synthetic division, I'm going to start with x to the second power. So I'm going to go down by 1. So 3 minus 1, power of 3 minus 1 becomes power of 2. So it's going to be, so down here, it's going to be 1x squared plus, and I'm putting plus because this was a positive 1, plus 1x minus 12. All right, and so if I look at this expression here, I can ask myself, can I factor this? So let me change the colors here. So I'm asking myself, can I factor this problem? And you can say, yeah, actually, I can use the table method. I can use the table method. So let me set up my table. So multiply 1 times negative 12. It's negative 12. Then the middle number is 1, which we need to add. Okay, so what two numbers multiply to give me negative 12, but add to give me 1? So I could do 4 times negative 3. That gives me negative 12. And 4 plus negative 3 is positive 1. So I get a check mark, check mark. Okay, so I would set up my parentheses. The variable is x, so I would put in x here, and then the numbers that worked are positive 4 and negative 3, positive 4 and negative 3. So positive 4 and negative 3. Awesome. So do I need to divide by anything? No, because the number in front is 1. So 4 divided by 1 is 1, and negative 3 divided by 1 is 1. So that's my factoring of this. Okay, so I can get x values from here. Right? Because we talked about last lesson that if I have factors, I can get x values from it. So what would we usually say, right? We would take this one and put x plus 4 equals 0, solve for x. Then we could bring this one down, x minus 3 equals 0, solve for x. So subtract 4, x equals negative 4, add 3, x equals 3. So when it's asking for the rational zeros, Again, zeros are x-intercepts. It's changing colors here, but zeros are x-intercepts. So we end up with three answers. X equals -4, x equals 3, and probably wondering what's the third answer, because I got -4, I got 3. The third answer comes from the value up here that we had tested. Remember, we had all these values to choose from. Our third answer comes from the -1. So my third answer is x equals -1. So these two answers, the -4 and the +3, came from this table method factoring process. And x equals -1 came from the synthetic division, the number that we were using for synthetic division. Okay. So again, we do all the p's over q, we divide them to give us a list of possible x-intercepts. These are all possible x-intercepts. And then we test it out using the smallest one, right? We tried out +1, but it didn't give us a remainder of 0. Then we tried -1, and we used synthetic division, and then we got a remainder of 0. Then we wrote the expression that comes out of the synthetic division. And we asked ourselves, can we factor this expression? And we did using the table method. Then we found, we set the factors equal to 0 and solve for x. So that gave us 2 answers here. And then we got a third answer from the synthetic division. And we should end up with 3 answers. Let me zoom back in here so we can see. I can tell you right now that I knew beforehand that we were going to end up with 3 answers, because there's usually as many x-intercepts as there is a power, as the highest power in the expression. So since the highest power was the power of 3, we ended up with 3 x values. Okay. All right, so let's look at, let me zoom back out here and let me go over to example 2. Okay. Keeps looking crooked. Okay. So the next one, we're going to practice the p over q again. So p is the value that's at the end here, and q is the value at the front. And so for the p value, what are some different ways to multiply to get 5? 1 times 5. We're going to put plus minus, plus minus. Then for the q, what are different ways to multiply to get 2? Just 1 and 2. 1 times 2. Then we're going to do all the p's divided by q. That's going to equal to, what's 1 divided by 1? 1. What's 5 divided by 1? 5. Then let's try the other, dividing by the other q. What's 1 divided by 2? 1/2. And then what's 5 divided by 2? 5/2. So all of these are going to be plus minus, plus minus, plus minus, plus minus. Okay, So now that we found all the potential x-intercepts, potential means that they could possibly be an x-intercept, but we're listing all the ones that they could be. Now that we've listed them, remember, we're going to do synthetic division. So we're going to copy the values in front of the x's here. So 2, -5, -2, and 5. So 2, -5, -2, and 5. Set up the synthetic division, bring down the first number, and then test out which one's going to work. So again, let's try out +1. I usually like to start with the smallest one. Let's try out +1. What's 1 times 2? 2. What's -5 plus 2? It's -3. What's 1 times -3? -3. What's -2 minus 3? That's -5. What's 1 times -5? 1 times -5 is -5. And then what's 5 minus 5? 0. So my remainder is 0. Awesome. So x equals 1 is one of my answers. It's one of my x-intercepts. Okay, and same idea as last time. What did we do with the leftover values here? Since we said that the highest power was the power of 3, we're going to go reduce that by 1, so the power of 2. So it's going to be 2x to the power of 2 minus 3x minus 5. Again, I'm using the 2 from here, the -3, and the -5. Then we ask ourselves the question, let me use a different color. Can I factor this expression? And we should say, yes, we can. We can use the table method. And so we're going to multiply 2 times -5. That's -10. Then -3. We're going to look to add. So two numbers that multiply to give me -10, but add to give me -3. So we could try -5 times +2 equals to -10. So check mark. And then what's -5 plus 2? That's -3. Another check mark. Okay, so I'm going to make this table a bit smaller. All right, so we are going to set up the parentheses. My variable is x. The numbers that worked were -5 and 2, -5 and 2, -5, +2. Okay, so I got x minus 5, x plus 2. So those are what it's asking me for at the bottom here. So my factors are x minus 5 and x plus 2. And I actually have a third factor. The third factor is going to come from x equals 1. This x equals 1 that I had over here. bring it down over here, and then do the opposite. What's the opposite of positive 1? Subtract 1. So I'm going to subtract 1 on both sides. That's going to give me x minus 1 equals 0. And so this x minus 1 is my third factor, which I'm going to copy down here, x minus 1. Okay, and so that brings me to the end of the notes. Thank you for joining me today. I'll see you guys in class, and then we'll discuss this a little bit more if you have questions. Have a great day, guys.